So this is the problem from the section in the textbook. So it's just like the ones out on my math lab. And so what are they giving us? They're telling us we've got a rectangular plot of farmland bounded on one side by a river. So here's the river, and then here's the fence, and they're telling us it's a rectangle. And this is illegal, by the way, because you're not supposed to, the animal's supposed to be fenced away from rivers so they can't get in it. Phosphate and all that, phosphorus and stuff. So the other three sides have a single strand of fence. So we got 800 meters of wire to deal with. And since this is a rectangle, that's x on both sides. And won't this be the leftover? 800 minus 2x. And then so now we want to maximize the area. So length times width equals the area, which would give me 800x minus 2x squared. Now, what we've got going on here, just so you know, you might have done this in college algebra and algebra 2, and what this is a parabola, right? This is a parabola that opens down. So, but you can remember without using calculus. Now, I want you to use calculus for this because this is a calculus course, but I'm going to show you how it relates to what you've done earlier in your mathematical life. So here's A, here's B. So negative 800 over 2 times negative 2. So that's going to be 800 over 4 because the negatives cancel out. So when x equals 200 is when the x coordinate of the vertex, and then to find the y coordinate of the vertex, well, actually that would be the area. We don't really want to find the area, we want to find the dimension. So if this is 200 and this is 200, this has to be 400, right? 800 minus 200, 800 minus 2x, x is 200, okay? So that was the dimensions, 200 by 400, and because we know this is a parabola that opens down, that's the vertex, that's going to be maximum, all right? So that's doing algebra. What if we want to do calculus? And the other thing I want to say is this situation where this is always a quarter of the total amount of fencing, this always works in this ratio. So really nothing surprising with these fence bounded with a river problems. So how do we do this using calculus? Okay, so we want to find the derivative. So that's going to be 800 minus 4x. And we want to know when does that equal 0. So where does 4x equal 800? Well, x equals 200. How do we know if that's a maximum or minimum? Well, we know, but how do we know? Well, we want to take a look at our derivative and then test signs. Here, let me get this out of the way. Can I get that out of the way? I don't know if I can. So I know I have endpoints of 0 and, well, let's see, it would have to be 400, right? Because I couldn't have more. If each side of that fence is 400, that doesn't leave anything left for this dimension. So we know 400 is the upper end. And then we just got 200 as the critical value. So now let's substitute a number in left of 200, like 100, or how about 1? So when x equals 1, let's see, this is my derivative. When x equals 1, y is a positive number, so the derivative is positive on that side. And when it's more than 200, say like 399, that's going to be negative. And so yes, this is indeed a maximum value. When x is 200, this is a maximum value. So then you do the same thing. If you know you've got the, what is it, 800 minus 2x as the length. So same answer, right? We're going to get 400 as the other one. So that's using calculus, okay?